Hello and welcome to the video on logistic regression. Logistic regression is one of the most popular classification algorithm, and in this video I'll teach you the math behind it and also show the practical implementation in SQL and Python. So let us start. Logistic regression is one of the most popular machine learning algorithms which comes under supervised learning technique. Now, it is used for predicting the categorical dependent variable using a given set of independent variables. This statement is also true for other classification algorithms. Now, logistic regression predicts the output of categorical dependent variable. Therefore, the outcome must be a categorical or a discrete value. It can either be a yes or no, or in mathematical terms, we can say 0 or 1, or true or false, etc. But instead giving the exact 0 or 1, it gives the probabilistic value that lies between the range of 0 and 1. So this is the key point for logistic regression. Remember this statement and logistic regression will be very easy for you to understand. So logistic regression is much similar to the linear regression, except that how they are used. Linear regression is used for solving regression problems, while logistic regression is used for solving the classification problems. A lot of students are confused in the name of logistic regression. By the name, they think that it will be a regression algorithm, but actually logistic regression is a classification algorithm. So remember this point. Now, in logistic regression, instead of fitting a line that we used to do in the linear regression, that was y is equals to mx plus c, we fit an S-shaped logistic function which predicts two maximum values. Either it will be 0 or 1 on the maximum side. The curve from the logistic function indicates the likelihood of something, such as whether the cells are cancerous or not, mouse is obese or not, and based on its weight, etc. So logistic regression is a significant machine learning algorithm because it has ability to provide the probabilities and classify the new data using continuous and discrete data sets. Logistic regression can be used to classify the observation using different types of data and can easily determine the most effective variables used for classification. So let us understand logistic regression with the help of this image. So here we are setting the threshold value on 0.5. So anything or the probability that logistic regression gives, let's say it predicts y is equals to 0.8. As 0.8 is above the threshold value of 0.5, so we'll consider it 1. And for example, if logistic regression predicts that y is equals to 0.3 and based on a threshold value it is less than 0.5, so we'll predict it as 0. So this is how logistic regression works with the help of this S curve. So you can generate that S curve with the help of this logistic or sigmoid function. It is just another mathematical function and it has a curve like the S shape that we already saw. So the sigmoid function is a mathematical function used to map the predicted values to the probabilities. Now it maps any real value into another value within the range of 0 and 1. The value of logistic regression must be 0 and 1, which cannot go beyond this limit. So it forms a curve like S form. The S form curve is sigmoid function or the logistic regression function. In logistic regression, we use the concept of threshold value, which defines the probability of either 0 or 1, such as values above the threshold value tends to be 1 and values below the threshold tends to be 0. This we already discussed. Now, these are some of the mathematical equations that are important for logistic regression. So the logistic regression equation can be obtained from linear regression equation. The mathematical steps to get logistic regression equations are given below. So we know the equation of a straight line can be written as y is equals to b0 plus b1x plus b2x2 plus b2x3 and so on. In logistic regression, y can be 0 and 1 only. So for this, let's divide the above equation by 1 upon 1 minus y. So y upon 1 minus y, 0 for y equals to 0 and infinity for y equals to 1. If you divide anything by 0, it becomes infinity. And if you so we need the range between minus infinity to plus infinity and take any logarithm, then take the logarithm of the equation and it will become log of 1 upon y upon 1 minus y is equals to b0 plus b1x1 plus b2x2. So this is how you derive the equation of logistic regression. Now enough of the mathematics. Now let's move to the Jupyter notebook and try to implement the logistic regression algorithm in Python. So let us start with the practical implementation of logistic regression. I have imported pandas and numpy. Now let me create a data frame. So let's name it df and we have pd.read CSV, and the data set that I'm going to use is user data.csv and df.head. Let us see what we have in the data. So these are the columns that we have. First is user ID. This we are not going to use. So gender, age, estimated salary, and purchased. Now gender tells about the is a feature of the customer, age and estimated salary, and purchased tells that whether the customer has purchased that item or not. So if we have the value of purchased as 0, then probably the customer has not purchased that item, and if we have purchased is equal to 1, then the customer, he or she, has purchased that item. Now we already have a good idea about the all the features that we have in the dataset. Now let's separate the x and y, or the dependent or the independent features. So df dot iloc, and here what I'm going to do, so 2 comma 3, and then a closed bracket dot values. So this will be our x. We'll do the same for y. So df.iloc, let me copy this and I'll paste it over here, and I only want 4, or the purchased or not purchased. So this will be our y. So let me see what do we have in x, and y is the 0 and 1. Now let's train and test. Let's split the dataset into train and test. So from sklearn.model underscore selection import train test split. Now I'll make x train, then I have x test, then I have y train, and I have y test, and this is equal to our x and y that we already made. So x, y, and test size, let's keep it 20% of the data for testing. Okay, so this we are having an error. Okay, I have to write train test and split. So now we have x train, x test, and y train, y test. Now let's perform scaling. So from sklearn dot pre-processing import standard scalar. Now let me create the instance for the scalar. So standard scalar for x, and this will be an object of standard scalar. Now firstly I'll fit transform on x train, and again I'll store it back into x train. So st underscore x dot fit underscore transform, and this is again x train, then x test will be st underscore x dot transform and x test. So now we are done. Now let's import the logistic regression model that we are going to use. So from sklearn dot linear underscore model, we will import logistic regression, and I'll create one classifier object. So CLF will be equal to logistic regression of, and then I'll fit or train this model on x train on y train. So let me give the training sets x train and y underscore train. So now we have the trained model ready. Let me predict the results and store it into ypred. So CLF dot predict, and here I'll use x test. So let me see what do we have in ypred. So these are all the predictions that the model has made. Now let's test the accuracy of the dataset with the help of a confusion matrix. So from sklearn dot matrix import confusion underscore matrix, and I'll plot the confusion matrix. So confusion underscore matrix, and this is for y red and y test. So let me see what do we have in CM. So what we are getting is the confusion matrix. As you can see, we have lot of elements present in the diagonal part of the confusion matrix, hence the accuracy is on slightly on the medium to high side. So hence we can say that logistic regression is a decent classification model on this data set. Now let's move to the next video if you are clear with the concept. So thank you for watching.